Welcome to my talk, Make It Fast, Simultaneous AI Actions in Gears Tactics. My name is Matthias Simonsmeier and I'm lead AI programmer at Splash Damage. Splash Damage was founded in 2001 and we are based in London in the UK. Over all of those years we have worked on a lot of different titles and our latest release is Gears Tactics. A few words about this talk before we start. This talk will not discuss the enemy designs itself, but the implications of some of our designs for the AI system. I would also like to take the opportunity and point out that what I'm presenting here today is the effort of a whole team, and I would like to thank everyone involved. Special thanks also to our partners at Microsoft and the Coalition. So what are we actually going to do here today? Firstly, I will give you a brief introduction into Gears Tactics in case you don't know the game. Afterwards, we will talk about the requirements for the AI system, followed by the AI system itself, where we will focus on how we made the turn fast. Afterwards, we have a small section about debugging, followed by the concluding discussion. So let's get into Gears Tactics. Gears Tactics is a fast-paced, turn-based spin-off game to Gears of War. We released on the 28th of April this year for PC, Steam and in the Windows Store, and the story is set 12 years before the first Gears of War game. So if you're familiar with the franchise, we are talking about the Hammer of Dawn strikes and the fight against the Locust. I will show you our release trailer so you can get a better overview.
Okay, cupcakes, listen up. Forgive us, this is the only way.
So what's next, Mustache Man?
It's Sergeant now. Ukan.
Oh, really? And how are we gonna do that?
Think I know a guy.
Hey! Over here!
Don't you worry. Been working on my recruiting pitch. All right, you're with us now.
What else aren't you telling me?
We're in for a fun ride, you and me. Engaging now. Get hit, catch good! Ha! Louis! Your history.
How is that even possible? That's insane.
Bring it, shitheads! I missed you too, asshole.
So let's talk about the requirements for the AI system. In the very early days of this project, we were just prototyping a tactics game in the Gears of War universe, and we were trying to figure out what this actually means. We put the first enemy prototypes into the game, and we wanted to settle on the vision for the AI. At this point, we met with our creative director, and he looked at us and said, "Make it fast." So we created the following goal statement. We wanted fast-paced enemy turns, without losing tactical clarity, in a game with a high enemy count, and free movement, live bullets, semi-procedural generated maps, and all of this while supporting an immersive world. Our basic idea was to pre-plan the whole turn and then find actions that we can execute at the same time. This means all of our decision-making systems are only queuing abilities while they are planning, they are not executing anything. Also, we wanted to let each unit plan the turn for themselves, so we don't have a concept of squads, which makes it easier for us to implement and change the unit's behavior. Before we go further with this, we need to discuss what combo moves are. Combo moves for us are actions that involve more than one unit. It enables us to execute actions at the same time, which will lead to faster enemy turns and better camera framing. It also ties into the immersion for the player, because units seem to work together. They can play animations, voiceovers, special cameras, or comment on each other's actions. The big problem here is the tactical clarity. As soon as we start executing actions at the same time, it's very hard for the player to parse what's going on the battlefield. And this is what we mean with tactical clarity. The player needs always to be aware what's happening on the battlefield to take tactical decisions within the player's turn. So let's look into the AI system that we have built. Our AI system is a very layered approach. Each layer is connected by the common interface, the plan. Each layer passes on a plan to the next layer. The plan then goes through all of the decision-making layers and arrives at the plan execution at the end, where we execute the plan and we see the behavior on screen. In our system, we start with the level scripting. We then go to the goal planner, where we handle a subset of combo moves, followed by the unit planner, and then the combo move analyzer, where we handle another subset of combo moves. We will look at each of those layers briefly, but we will focus on the combo move analyzer later. Before we do this, though, we have to talk about the plan. So the plan is the common interface between the different systems. It's nothing more than a list of nodes, and the nodes can be of type ability element or sync element. An ability element is the triple of the unit, who is going to do something, the ability, what needs to be done, and the payload, how are we going to achieve this. The payload can contain the target to shoot, for example, or the location to move to. It's very dependent on the ability itself. But the payload can also contain already hit and miss information, and we will see in a bit why this is so important for us. The other element in the plan is the sync element, which acts as a marker. This marker is used during plan execution. So we start now with the plan execution layer. In the plan execution, we execute all elements from the plan in the order up to the next sync element. We wait for them to finish, and then we repeat until all elements are executed. So here's an example, and I will use this notation throughout the talk. We have unit A wanting to move into this location over here. The number next to it corresponds to the time of planning. So the first action we plan is a movement action into this location, and the second thing we plan is unit A wants to shoot this player unit over here. So we reflect A wants to move, and then A wants to shoot unit X. And then we have a sync point. The next thing is unit B wants to move into this cover location and shoot player unit Y. Lastly, unit C wants to go into this cover location and shoot player unit X. So when we execute the plan, we assign all of the elements to the unit until the next sync point. So we start by assigning the move action to unit A and then the shoot action to unit A. The unit will execute all of the elements in sequence. We wait for them to finish, and then we repeat the whole process until the whole plan is executed. The question here is now, how can we make this turn faster? The first idea would be all of the units act at the same time, we have a really fast enemy turn. But this is what we mean with tactical clarity. It's very hard for the player to pass this when more than one player unit is attacked at the same time. So our first rule of tactical clarity follows as we don't want to attack more than one player unit at the same time. So it follows we only want A and C to act at the same time. When we talk about all of this planning and the planning order, there are problems we need to solve. So the first one is we have two units and they want to go into the same cover location. Obviously only one of the units can take it, so there's a conflict when we execute this. The other example is a unit moves to a location and another unit wants to shoot a player unit, but the first unit is now in the way. How do we overcome this? It basically means we need to expose the effect of abilities to the next units that are planning. And we do this by using the world state. Our world state is a little bit different from what you might know from systems like GOAP. For us, the world state is a representation of the world. We have the actual values in our world state, for example, health values, status effects, and so on. Whenever we queue an ability, we only change the world state. So for example, we queue a shooting ability, so we change the damage value of the target in world state. And this is where it comes in that we already have the dice roll in the plan element, in the ability plan element, instead of when we actually execute it. At this point, we know what's going to happen. We don't use it in the unit itself that is planning, but we pass it on to units that are planning afterwards, so we are not cheating. The important bit is because we pass this information on through the world state, we can only query information from the world state during planning, and not from the real world. What this also means is that the world state needs to be as accurate as possible. We need to make sure that all of our systems can deal with this kind of system. Once we have done this, it allows us also to plan while other units are executing already. So we get a big performance boost here. So now let's go through the first layers very briefly. We start with the level scripting. It's very blueprint driven, and scripters can queue abilities for each of the units. Scripted units are ignored for goal and unit planning afterwards. Combo moves are created in the combo move analyzer later on, so scripted units and non-scripted units will be taken into account and can act at the same time. In general, we use our goals in the goal planning layer for global tactical decisions. So for example, push a player unit out of cover before other units are attacking this player unit. But also for very high level decisions. For example, should we defend an objective? Or should we rush the player in the current game situation? Another thing we do in the goal planning layer is decisions that cannot be taken by the unit itself. So for example, who is best suited to heal a friendly unit this turn? Or to execute a DB&O enemy unit this turn. DB&O is a Gears of War term. It's the state when your health is depleted, you are crawling on the floor, your friends can revive you, but enemies can execute you to finally finish you off. Our goal planner under the hood is nothing more than a job assignment system based on fuzzy conditions. Whenever we start a new enemy turn, we have the turn set up where we update all of the goals, create all of the instances, and so on. Afterwards, we run the fuzzy conditions to assign jobs to units. Once the unit has received the job, it plans against this specific job by executing a special behavior tree for this job. The result is then returned back to the goal planner, and the goal planner updates all of the goals and continues the process until either all goals are fulfilled or we don't have any units left that can do any of the goals. The layer afterwards is the unit planning, and the unit planning is a behavior tree with a default behavior for each of the units, taking their characteristics into account. It deals with the actions that were not used during goal planning, and what we mean by that is a goal could ask you to go to a specific location, but then the unit might have action points left over. So the unit planning layer looks at this, looks at how many action points are left over and what the unit might want to do with this. For example, reloading a weapon or shooting a player unit or similar. Again, I remind you that all of those layers just queuing abilities into the plan. No execution here. So now we get to the combo move analyzer. And the combo move analyzer, the problem that is presented to us here today is we have a sequence of actions, and we want to figure out what can we do to execute stuff at the same time. So we take a plan and we reorder and merge elements into combo moves. The tactical clarity for the player is really important here. So I remind you on the first rule of tactical clarity, we don't want to attack two different player units at the same time. I will show you a video now without combo moves, and then the exact same situation with combo moves. So here we have a very traditional approach, no combo moves. Planning is still happening in the background, but you see the units are coming out of the fog of war one by one. This unit is a Wretch, it's a fast-paced melee unit in our game. I speed up the video now because, as I said earlier, we have a lot of enemies in our games. And you can see here, they are all coming one by one. The whole turn takes us 66 seconds to execute. Now the exact same situation, just with combo moves enabled. And what we see is we have a group of wretches coming at the player at once. And then another group of wretches coming at the player at once. So the whole turn only takes us 15 seconds. Let's look at an example. So in this example, we have a enemy unit here in cover already, wanting to shoot at a player unit X. Then we have a unit B that wants to move into this cover location and shoot this player unit over here. And lastly, we have a unit C that is aware that B will move away, so it wants to take this cover location and shoot this player unit over here. So this is how our plan looks like. And we say, okay, A and C are attacking the same unit, and let's assume they are frameable by the camera. So we want to create a combo move. A and C should shoot at the same time. In order to do this, we need to find the pre-ability for C. C needs to move into this cover location over here before it can actually shoot. So our combo move is C should move and then A and C are shooting. The full plan for this turn becomes now we execute the combo move and then we execute the actions of B. But obviously there's a problem here, because the movement of C will fail. The location C would like to take is still occupied by unit B. So B needs to move away first before C can execute the movement there. What this means is we need to check for pre-combo moves and occupied locations when we do the reordering. So our plan for this turn becomes, oh, B needs to move first. It needs to make the space for unit C to take this cover location. Then we execute the plan, and then we have B shooting at the player unit. The big question here is, should we really split the actions of the unit? And our answer to this is no, for tactical clarity reasons. It's very hard for the player to pass what's going on if we start splitting the actions. Let's assume this combo move here can be much, much, much bigger. A lot more things can happen here. So we show a unit to the player, then we move the camera away, show something else in the game, and then at some point we get back to this unit and see the shooting. It's very hard for the player to connect the movement and the shooting of this unit now. So we don't want to do this. Our second rule of tactical clarity is we don't want to split the actions of a unit as much as possible. There's a point about cycles here. It's not always possible, but we try to keep them as close to each other as possible in the plan. So our final plan here becomes B should move and then shoot. We have a sync point, we wait for this to finish, and then we execute our combo move, and A and C are moving and shooting. This example we call the concentrate fire combo move. Multiple units are attacking the same target. What this means is units might need to execute other abilities before shooting, for example the movement as we have seen before. But it also means in our game we have attacks that might push back the target. So the target might get out of line of sight. Effectively, the location of the target changes during the execution here. For tactical clarity reasons and for line of sight considerations, we say those actions need to play exclusively. We don't combine them with other shooting actions, for example. If a pushback is applied from an action, it is played on its own. So the player can understand which unit applied the pushback to the player unit, but also for the line of sight considerations that we have planned. For the line of sight considerations, we add another rule and we say units that have planned before or after the pushback need to act before or after the pushback. So we can never reorder over the point of a pushback. When we talk about all of this, it's really, really important to talk about the player perception. At the end of the day, we create a game for the player. So in this example, we spend a lot of time on planning and then we execute the full turn, all enemies at once. And you see it took us 7 seconds to plan this turn, and it takes us another nearly 8 seconds to execute this turn. The second example, we spent less time on planning. So you see we start executing after 3 seconds, and then we have a group of wedges coming at the player, and another group of wedges coming at the player. So the execution of this turn took us 12.2 seconds. Overall, the time from the player hitting the end turn button to being back in the player turn in the first example was 15.5 seconds, in the second example 15.1 seconds. So they're pretty similar. There's a big difference in the perception though. When we show this to players, we get the answer that the lower the player downtime is, the faster the enemy turn is perceived. The player downtime is the time that we measure when the player hit the end turn button up to the first enemy acting on the battlefield. What this means for us is we want to start executing early. We start while other units are still planning, which we can do because we have the world state and we know what the outcome of the actions will be. We can balance planning versus execution time. And overall, we want to reduce the player downtime, and this is much more important to us than the quickest possible turn. For example, we start executing as soon as we see a pushback action in the plan. We cannot reorder over the point of a pushback action anyway, so we can just start executing. But we also start executing, for example, after timeouts. Combo moves are generated at different times, as we have seen in the beginning. So we have combo moves during planning, for example, the push out of cover combo move, which is usually handled in the goal planner. And we have the combo moves that are generated post-planning, for example, the concentrate fire move that we have seen, which is handled in the combo move analyzer. Pre- and post-planning combo moves can be combined, so we can have a push out of cover and then have a group of units shooting the exposed player. Here's an example of that. We have our fast-paced melee unit over here, the Wretch, surrounded by 4 drones, which are ranged units. And what we can see here now is the first 2 drones decide to spend a lot of their action points in moving and then overwatching the player, but they do it at the same time. We see then the Wretch is coming in, exposing the player unit from cover, which gives the other drones a better hit chance, so they are taking a position to attack and then they are attacking at the same time. This made this whole turn really fluent. Another example is the command combo move. A commander unit appears to be telling other units to move or attack. There's no actual gameplay effect attached to it, but player and AI units can comment on the action. All of this is added post-planning, and we do it if we have a combo move with more than 1 unit moving. We have a commander unit in range. Then we simply put the command ability before the move abilities in the combo move and we're at a sync point. We then add some cooldowns so it cannot happen all the time. An example of this is here. We have a Theron Guard surrounded by multiple wretches. When I play the video now, please focus on the animation and voiceover of the Theron Guard itself, but also the reaction of the player unit. Before we look into the next problem, we need to quickly discuss how Overwatch works in our game. So in this example, we see a player unit taking off a cover location and then setting up an Overwatch cone. By doing so, the player unit moves out of cover, which changes the line of sight. During the enemy turn, all enemies that are doing actions within this cone will get shot. So we see we are going to the enemy turn now, and they are getting shot. The player can shoot as long as there's AP left or ammo left. So when this is depleted, the player returns to cover, which changes the line of sight during the enemy turn. So we see here now the player returns to cover and the line of sight is changed. The problem is that we rely on certain effects being applied. So in this example, we have a unit A that moves into this cover location and shoots this player unit over here. We expect from this shooting action, this player unit will go DB&O into the state where other units can execute it. And this is what Unit B wants to do. Unit B wants to move next to the player unit and then trigger an execution on this unit. I need to point out that this is only possible on higher difficulty levels. I'm not allowed on normal difficulty setting to DB&O a player unit and execute at the same time. I need at least 1 turn to wait in between to give the player a chance to revive their units. On higher difficulty levels, this situation is totally valid. So the question here is, what if A runs into an Overwatch cone and gets killed? This player unit will never go DB&O, so this unit here cannot execute this player unit. Our solution to this is what we call interruptions. We interrupt if something unexpected happens, and unexpected means for us something that we haven't planned for. We finish executing the current running abilities, and then we restart the planning from scratch. This can happen multiple times during a turn, so the planning performance is really important for us. But what it also means is that we need to keep track on what a unit has already executed. We have rules in our game that some units, for example, can only shoot once per turn, so we need to keep track if they have done it already or not. We do this by using the Blackbot modifications. In our system, we never modify the Blackbot directly. We have our queue ability node, so in this example we queue an ability to move, and then we have this structure attached to it, which modifies the Blackbot when we queue the ability, and what it does is it adds an int, so 1 to the number of moves. We just increment the number of moves on the Blackbot to use it in further planning. When we trigger an interruption, we know if we have executed this ability or not. So we can revert, if we haven't executed this ability, we can revert this data, bring the Blackbot into the state that we can plan again. There's one question that you might have: why do we not plan for everything and make interruptions obsolete? The answer to this is twofold. So the first part is that the player needs to feel clever about the usage of Overwatch and planted grenades and so on. So we don't really want to factor this into the planning of the units. We can still do it by just exposing the information to units planning later on. We would get less interruptions. But there's a big problem here, and this is predicting Overwatch in a free movement system with live bullets is really hard and costly. Also, players return to cover after Overwatch is triggered, for example. There are multiple things in our game that have those impacts. So overall, we decided it would mitigate the problem but not solve the issue. And during the development, we would play catch-up all the time with every change in the game. So we needed some form of interruptions. Now I will talk very briefly about debugging. So we use the Visual Logger a lot. The Visual Logger comes out of the box with Unreal. If you haven't used it so far, start doing it. It's a really useful tool. All of our systems log to the Visual Log file, and the Visual Log file for us is automatically generated for every game that is played in non-shipping builds. We had a huge success in investigating issues with those files. The process was basically the QA found a bug. They created a bug ticket, attached the Visual Log file. We received the bug ticket, looked into the Visual Log file, and we could understand what was going on. So here's an example. This is our turn manager over here. You see all of the events are logged at different time frames. At this specific time frame over here, we see this data. So what we get in is units have planned the turns for themselves. All of them want to move and then Overwatch or move and hunker down. Then we have the plan after the combo move analyzer analyzed, and we see all of the movement actions are combined over here. Okay, so this brings us to our conclusion. So our world state allows us to plan while other units are executing their actions. All of our systems need to support simulation of outcomes for this to work, but it gives us a big performance boost. The common interface between the different layers in our system makes it really easy to experiment and replace whole layers without changing the system itself. We have to admit, the initial overhead for pre-planning was massive compared to a traditional approach. But once we have done this, implementing new behaviors was really easy for us, and we never had to go back to understand how can this now interact with another ability that might be playing at the same time. The system was just handling all of this for us, so we could focus on the implementation of the behaviors, which was a big benefit for us. Overall, we feel we did speed up the enemy turn drastically, and we also feel that the gameplay feels much more action intense and ties into the immersion for the player. I have to say there are many more things that we did to speed up the enemy turn, which are unfortunately out of the scope for this talk. So thank you very much for playing our game, and I'm happy to answer all of your questions now. Thank you very much.